What's going on, Internet? So, have you ever heard of the 4 minute mile? Where for many, many years, people were trying to break the 4 minute mile. And one day, a guy broke it. And then only a few weeks later, another person broke it. And then another. And then another. And then over time, they all started breaking the 4 minute mile. It took that one person to break it for everybody else to follow suit. That same thing is happening with deep research right now. Google launched deep research in roughly December. And then only a few months later, around February, almost every other big AI provider started dropping their version of deep research. But there are a few interesting things that I've not really seen people talking about in relation to deep research. And it's primarily how these kind of agents function in the back end, specifically how they actually prompt a user. And then also in the future, when these deep research agents are applied to our corporate data sets privately, what the value unlock's actually going to be there. So today what I want to do with you is I want to walk you through a demo, initially obviously, and then walk you through exactly how these things function, at least from my understanding of it, and also what the potential future could be like utilizing these agents that are deep research oriented. And as you can see, as always, we'll start with slides and we'll annotate our way through this video. So first, we have this beautiful character that we're going to follow. And we're going to follow them to a demo. Now our demo is going to include different opportunities to use deep research. So I'm going to compare Perplexity, Grok, ChatGPT, and also an open source variant. And the question we're going to ask is going to be around deep research. It's going to be very meta. We're going to have deep research itself. Okie dokie. So we have our example here, our prompt. So the prompt here is basically asking, in simple terms, explain to me how the AI deep research feature works on the back end, specifically talking about Google, OpenAI, Perplexity, Grok 3, and open source variants. Open source. And also, I want to know the future of this tech and how it looks, taking into consideration lowering costs and latency associated to AI. So this is the prompt that we're going to give to all the deep research tools here. So I'm going to do enter here, do enter here. Oh, here we go, on Perplexity. And then for the open source one, we need to go to the terminal. So quickly, I guess, to explain this, and actually I'll run it, and then we can talk about how it functions. So I'm gonna run it, and then also, actually, should I explain this? I'll explain this in brief detail, and I'll explain it more in depth. So it's asking me what's the research depth. We'll go with 4. For this, we'll go with 3. It's basically saying how many questions should you ask in concurrence, and then how many times should you ask these questions. So it's going to start doing some stuff. And the interesting thing here is that already the open source variant is asking me questions, and let's see if they're doing it as well. So yeah, so this is, could you clarify on some stuff? This is, looks like it's just going at it. And so is Perplexity and Grok didn't ask me questions, but OpenAI and this open source variant are. So the following questions are, could you clarify what specific aspects of deep research tools you'd like to focus on? Here are some possible areas. How they gather and process any information, differences between Google, how they handle cost and latency, their impact on research workflows, predictions for the future. All right, so I'm just going to say, let's do all. Okay, and then we can see that the open source variant is asking a question of, do you want a unified overview of these tools, architectures, comparative analysis focusing on specific backend mechanisms employed by each, So for this, let's say you choose. Are you interested in simplified explanations for non-technical audiences? Sure. When discussing the future of AI research tools, would you like us to insight primarily on technical innovations? No. Let's be broad. Okay, so I've answered 3 subsequent questions that it's asked me, and I've answered a few questions for OpenAI as well. And that's one of the primary things I wanted to point out here, is that when you're using these deep research tools, this is one of the very first widely adopted use cases where the AI is actually prompting the user and the user is not solely prompting the AI. And in my head, I think that's where most AI should go and will go in the future, because oftentimes we humans don't necessarily know what we want to ask. We're basically just asking whatever. And if the AI has a better insight or intuition as to what we should want based off of the scenario we're in the context it understands about us, then it should be asking us and poking us and prompting us instead of us doing it vice versa. So I think this is one of the first baby steps towards a world where a lot of AI prompts us instead of us prompting them. That's one of the first things I wanted to mention. You can see this research is still undergoing, which is cool. And really cool thing here with all of these, except for Perplexity, maybe it did earlier, is you can see the process that's happening and what's going on. So you can see it thought about the question I asked it. It's exploring the AI research tool, so that means it's doing research. It's researching cost and latency, and you can see all the different things it's researched. So it's browsing results. It opened up a very specific resource. It's giving you kind of insights into each of the resources it was researching. Then it gives you more sources, and it keeps iterating on this process. Same thing applies for deep research. So you can see that this is actually running the longest. Of all the different tools that we've ran, except for the open source variant, OpenAI is running the longest. And you can see it has 14 resources, the resources it's going to, and it's, I think these are the queries that it's running. Article seems to, okay, no, these are the insights, so summaries of what's happening. Let's see offers. Yeah, so it's basically giving you brief summaries of what's happening and what it's reading and what it's consuming, which is really interesting. And it's intentional, right? So these companies are providing this transparency because they want you to see what's happening under the hood to a certain degree. Not all of it, but some of it. And as these work, I'm actually going to go off and explain more of the presentation, and we'll come back and look at the conclusions at the end. So the first thing here I wanted to share with you is, how does this operate in the back end? What are some of the major categories of things that are occurring? So first is the breakdown. So the breakdown is when we asked a question, we asked our primary question, which was understanding deep research on the back end. It then will, in the back end, break this down into subsequent questions. So we'll have sub Q1, sub Q2, and then continuously over and over and over, it'll create all these subsequent questions based off of the macro question. So it's breaking it down into subtasks or sub-questions that are easier for the AI to research and understand the answers to, and then it'll then synthesize and consolidate that later on. So this is a big piece of what's happening. Next is it's going to analyze the answers. So it's going to analyze these subsequent answers that it gets from each one of these things that it's broken down and researched. And when it does that, it's going to actually save itself a lot of effort and time, because it's not necessarily finding the answers to a question that wasn't initially asked, or it's not answering the question that actually matters. And a simple way to consolidate this is basically it's looking through the noise to find the signal. And then for the planning stage, this is where I would say a lot of the magic happens. And this is where we're using reasoning models most of the time. So each one of these different offerings that people provide, they have reasoning models in the back end. So the open source variant, I think, uses O3 Many. The OpenAI one, I think, uses O3 Many High. The Grok one uses Grok 3, obviously. And then Perplexity, I think, uses probably either R1 or O3, probably O3 Many. And the cool thing about planning is that what happens here is as it iterates through each one of these questions, it actually changes its plan over time. And we could sometimes see some of that when we're looking at the activity here. So you can see that if we read deeply into some of this stuff, it starts with a subset of questions. So I don't know if it can go all the way to the top. Okay, so it's gathering this information. And then as it gets more and more questions, it decides what additional questions should I ask based off of the previous answers I've received. Now, a simple way of showing this is, say we've asked question 1. And from question 1, we've broken that down into a bunch of subtasks. And then from that, we've gotten an answer here, answer 1. And answer 1 is going to dictate what the primary question 2 we're going to ask is. And this is where the reasoning comes into play. So as a reasoning model, I can think about the previous answers and then predict what I should, not predict, but assess what I should do next. So that's the planning phase. And then after the planning phase, we generate in transparency. So generate is when we're basically creating the report. And then the transparently piece is really important. Another really important piece of all the features of these tools, which is citations. So if you look at all these different reports that we've gotten back, they're all going to have citations to what they've actually pulled. So if we come down here, we have the report and there's a bunch of information, but you can see there's links out to blogs associated to what they actually pulled. And if we click into any of these, it's going to give you the blog itself. Some of these actually give you the linked text. I don't know if all of them do it. Let's see if this one does. So Grok and Perplexity don't, they just show you the whole article. But either way, they're giving you citations to what they're stating here, which is a really important piece for all of these tools because they want to increase trust with the users. Because if I'm a business analyst or a finance analyst, I need to ensure that the information I'm getting from these AI are actually accurate. So I need to validate that in a simple way. And by having citations in line with the text, I can quickly go to that and validate if it's true or not. So the next thing here is the interesting timeline. So this goes to the 4-minute mile statement that I made previously. So on December 11th, Google released Gemini Deep Research. And only 2 months later, OpenAI released their variant of Deep Research. And then right after that, we had a huge kind of, what's the term? Cambrian explosion. That's what it is. My science teachers will be proud of me. So when this happens, you can see all these different companies are creating their own variants of deep research. So February 2nd was OpenAI. February 2nd, right after OpenAI, was the open source variant, which is kind of weird. February 14th was Perplexity. 19th was Grok. And then recently, I think yesterday, there was another smaller startup that released their own variant of this in March, and they also announced a potential feature that allows you to apply this deep research idea to your own private documents inside of your corporation, which is another interesting fascination here that I truly feel that the most value that's going to be derived from deep research for most people is being able to apply this feature to their own documentation, to have a lot of internal kind of update reports and monthly reports and quarterly reports and things like that. Having all that synthesized and automated with AI, it's going to save so many people time, because most of the time, if you really look at corporations, probably 60 or 70% of the time is reporting back and forth to each other, communicating where progress is on projects and what's happening inside the organization. So if you can cut all that out, you save a lot of annoying effort and time that people are spending just consolidating data and sharing reports. So now we're going to kind of look at some of the primary things that I feel are important associated to these tools, kind of the nuggets that actually matter that make them unique in a sense for these deep research features. So first and foremost, like I said previously, is reasoning. So this is going to be probably one of the most important things, that we're using reasoning models in the back end instead of one-shot generative models. And an example here that we've talked through already is when you ask a question, the model is going to reason through this and ask itself questions to try to think through this. So it's going to say, okay, to answer the user, first I should find information about A. And then it's going to think, okay, after I find information about A, I should then next look up B. And then it's going to go through this iterative loop over and over and over. And the way that this could look is something like this, where we start with thinking. So it thinks about the question it was asked. Then it creates a subset of questions and then searches each one of those questions. After searching those, it reads through all of that information. It then thinks about the answers it's gotten from those specific sources, and then it searches some more. And before it does that piece there, it actually thinks to itself, okay, after I found the answers here, let's ask another question that gets us closer to trying to achieve the intent of the first. So it searches more, and it iterates to this loop over and over and over and over, until it feels like it's gotten to a point where it has the right answer, and then it pops out and generates the report. And you can see that some of these tools, like Perplexity, happened immediately. Grok happened pretty fast. Deep Research probably just finished. It took around 6 minutes, actually, 31 sources. And the open source variant is done as well. So the speed at which these get answers to you sometimes is correlated to quality, at least today. And that's a really interesting thing here, is that I've talked to a lot of people that use these tools, specifically deep research, and they almost feel like if the tool takes longer, they're going to get a better response, which is an interesting and kind of a perception of humans around effort being associated to time. And I don't know how long it'll take for humans to actually disassociate from that like perception of the world. But as these tools get more effective and as the models get more efficient, the compute gets more prevalent and the cost of these things lower, and so do the latency, you're likely going to get really high quality answers in a few seconds instead of a few minutes or 30 minutes or 20 minutes. So it's an interesting thing now that matters around the time associated to getting the report, but that likely will be debunked soon, probably in the next 6 to 12 months. Okay, so next is RLHF. So this is reinforcement learning with human in the loop. So the TLDR of this term is that we're having a human give feedback to the AI to ensure that it's improving over time. And all this stuff happens before it's deployed. So everything here above this line is before you and I get access to the tool. So this is during the training phase. So we'll call this training, and we'll call this inference. And inference is when you and I have access to this. So we users are playing with the tool. Below that or above that is training. So during this phase, specifically Grok and OpenAI both used similar methods here, where they had a AI that was watching a researcher or a bunch of researchers doing research. And they would be asked questions like deep research would. They would go off and do the very similar process of going to websites, consolidating information, consolidating reports, and it would watch them throughout that entire process. And it would start to mimic what they did to get similar high quality outputs. And after time, that was then baked into its policy engine. So when it would go off and do this itself, it would then mimic those humans for research. So that's the reinforcement, or it's really hard to say, RLHF point of this phase. Next is in real time, there's no reinforcement learning. There is no when we're using it. But there are kind of reinforcement-like behaviors. And some of those behaviors are the ones that I mentioned previously, where we ask it a question and it goes off and researches that question. And when it goes to research this question, maybe it gets a bad answer. So let's say that it researches, let's kind of break this up. So we have the subsequent questions that it breaks down, right? And then after it's broken those down, it's going to go off and research each one of those. And then it gets a consolidated and synthesized answer. So before it moves to the next question it wants to ask, it's going to judge and say, okay, based off the answers I've gotten from these subsequent questions, are these close enough to this question, or are they high quality enough associated to this to determine if we should go to the next question? If not, it's going to backtrack and say, okay, maybe this question here, and let's use different colors so it's easier to see. Maybe this question and this question were bad questions to ask. So I'm actually going to rerun this instance of these sub-questions, excluding the one that was okay. So we'll actually exclude this one because it was good, but we'll actually rerun those two that I mentioned previously. We'll rerun these with different questions that we want to ask, because we can realize that those subsequent questions we asked weren't good enough. So there is a reinforcement learning factor here because it's kind of iterating back on itself, but it's not really reinforcement learning because it's not updating the weights and biases and policies inside of the neural network itself. All right, so next is search. So all these tools have search, and they all have different types of search, and that can sometimes dictate the quality of the responses you're getting. So for Gemini, they're obviously using Google. For OpenAI and Perplexity, they're using Bing. The open source variant is using a thing called Firecrawl, and then Grok is using something mysterious because I couldn't find an answer associated to what they used for search. And when each of these tools go off and make their searches, they're actually going to take these searches and the responses from the searches, and they're going to do a few things. So one is they're actually going to take those, the lessons learned from each one of these, and you can think of those as basically facts associated to the answer that you're interested in. And they're going to stash those away, likely in some sort of vector database. So vector, not VB, we'll do VD, vector database. And they're not going to stash the entire thing away. They'll probably just take some metadata associated to it or summaries associated to it and stash that away. And they're going to do the same thing potentially with next questions as they go along. So they then can come back and retrieve this when it's time to go for the next question and the next research. So they'll do the retrieval for the next questions to ensure that they're ready for the next subsequent macro question they want to ask. But then for the facts, they'll come to that when they need to generate the report, when they're at the very end of the process and synthesizing what they want to report back to the user. And then lastly is time and cost. And I mean, this slide is really straightforward. I think we're just going to do that because I think the time it takes to report out these pieces of research and also the cost associated is going to drop drastically, and it's already dropping. So for instance, with OpenAI, when they offered their DeepResearch variant, I think it started out with ChatGPT Pro, which is $200 a month, right? And for this, you were capped at, I think, 100 queries per month. They've already upped that to 120, and they've also granted access to Plus users, which is $20 a month, and they, I think, get around 10 per month. And then we have Perplexity, which actually already offers this for free for a subsequent number of calls. So I think it's like 10 to 15 calls a month. If you pay for Pro, for Perplexity, you get around 200 or I think 300 per calls per month. Grok 3 offers this for free to a certain extent. So they offer it with a capped, obviously, so you get a certain number of queries. Gemini offers it for, I think, $20 a month. So you can see the cost is already dropping drastically. And sure, OpenAI's research and their kind of output tends to be the best. But like I said, this is going to drop for a million different reasons. One is engineering, so they can figure out ways to run these searches simultaneously to lower the compute cost. They'll figure out ways to efficiently use more effective models throughout the process. So instead of using one big model the entire time, maybe use a subsequent kind of series of smaller models that achieve certain tasks, such as retrieving data, summarizing, things like that. And then also compute. So if we're throwing hundreds and billions of dollars of money at creating these massive supercomputer clusters, this is going to drop the cost of inference as well, which is what is taking all the time here, is because we're running compute at test time in a sense that it's running compute when we talk to it instead of just once. Okay, so now that we covered these kind of key areas that make deep research interesting, I wanted to give you a snapshot into how the open source variant operates, because this is one of the most in detail options that you can look at to understand how this works in the back end. So we have a little diagram here, and at the top we have two parameters. So we have our depth parameter and our breadth parameter, and we have our user query. So this user query is a question that we asked around deep research, and then this gave us the prompt for depth and breadth. So for breadth, this is basically asking how many questions do we want to ask simultaneously. So if I run a subset of queries, we have rounds to go through. So let's say there's, say, 3 rounds, And each one of these rounds here are depth. So how many rounds do I want to go? So let's say I want to go 3 rounds. And then the breadth is going to be how many questions we ask per round. So in this, say I want to ask 4 questions. 1, 2, 3, 4 per round. So this means that it's going to ask 4 questions simultaneously that are broken from our macro question, because we have our macro question. And then we have 4 subsequent sub-questions that are going to be broken off and then ran through this first round. And it's going to run those simultaneously. Once it gets its answers and its summary, then it's going to ask a new macro question, and then it's going to create more subsequent questions below that, the 4. It's going to do the same thing and run through the same process, and it'll do that 3 times. So that's what the difference is between depth and breadth for these parameters. Deep research here is when it does its research itself. And like I said, this is going to be O3 Mini for default with that open source tool. I tried using DeepSeek's distilled version of the 32 billion parameter, and it was garbage. It was really bad. I highly recommend using O3 Mini. And I think to use this, you have to be, I think, around tier 3 for the API for OpenAI. But if you, I think, make a request, you likely will get access to O3 Mini for tier 1 and 2, which is basically everybody else. So then we have these things called SERP queries. So a SERP query is basically a query for Google. So it's when you request a thing on Google, it gives you back a bunch of links associated with Google search. You grab those top 10 to 25 links, and then it does its research on those. That's all that is. Next, it's going to process the results. And once it gets the results, it's going to have 2 new things. So one, it has the learnings. So that goes back to the facts that I mentioned previously that we're going to stash away. And the new directions are going to be next questions. So next questions associated to our learnings. So we're going to stash those away as well so we can use them next. And then we have a decision point. So we're going to ask, okay, based on the depth we're at right now, is depth greater than 0? Meaning that have we already gone through all the rounds that were initially decided on for the depth section for all 3 of these? If not, we need to continue. So if we're not at 0, we'll keep going. We'll then take the next questions, our prior goal, our next questions and learnings. We'll then run this again in deep research. And if we have gotten to 0, we've ran through all the rounds for depth, we'll then get our markdown output. That's really how this specific diagram functions and how the open source variant works. And then the last thing here I wanted to talk through is the future of deep research. So with deep research, there's a lot of different things that could happen with these tools that will likely happen in the future. And I think I don't know if the priority of these are based off of likely which ones will happen sooner, but this is kind of just a random bunch of ideas that I came up with deep research's help around what this could look like. So first off, OpenAI has already announced, and I think some startups are already working on this, where you can actually include visuals in your report that you get back from deep research. So not just diagrams, but also charts. So it can actually aggregate data and synthesize data for you, acting as a data analyst or financial analyst, and inserting charts associated to each one of the segments of the report that are relevant. So that just makes it more captivating, but also more useful for a lot of people. So that's the first thing. The next one is actually having a more conversational experience with deep research. So you can already kind of do this today, where when you're looking through the response, so if I'm looking through the response for one of these in OpenAI, say I'm, interested in responding to this, I can actually reply here and then ask it something specific to this section, and it gives me a response to that. But it's not using deep research in the response. It's going to use a basic GPT-4o response. So it's kind of midway there, but not necessarily where it could be when it comes to being truly conversational, in the sense that maybe I can dig deeper into each one of these sections and not just write through text, but also a voice. So I could actually have a voice-oriented analyst that I speak with that kind of speaks out the report to me in a conversational manner. So they teach me and educate me in real time. And this is kind of a far-off idea that I don't know if I have documented here, but in this conversational sense, I'm not sure about you, but I used to watch Bill Nye as a kid in elementary school. I was thinking, wouldn't it be awesome if I could have a customized Bill Nye video made in real time for me based off of my interests? And it would be entertaining enough and captivating enough for me to actually consume that information. So that is a really interesting future that I'm sure that we'll see likely sooner rather than later. And then the next one here is memory. So a lot of the interactions that we have with deep research, it will likely start to keep some of that information in its memory. So when it interacts with you in the future, it knows previous things that you've researched and incorporates that into its existing responses to you. And this already happens a little bit with OpenAI, where it has a memory feature where it can remember some facts about you. So when you research things, it knows how to tailor it and make the context more relevant for you. But this is more amplified for deep research and has likely a longer memory span to say, okay, over the last 600 researches, I noticed that 502 and 404 had different items that were related to the one they're asking now. So let's actually incorporate that into this response, so it's relevant to the context we previously talked about. So it's just making it more timely and relevant for you. And then our next one here is having specialized researchers. So instead of relying on a monster model to do everything for us, maybe we ask a question to the model and then it divvies it up to a bunch of agents that specialize in very specific types of deep research. So maybe we have a chemist that's very good at chemistry. We have somebody that's really good at astronomy and somebody that's really good at history. So if we ask a question that really includes all the three elements, we have kind of like our master asker that we ask. So this is the user asking the question. We'll make this a little person down here. The really bad person. We'll try one more time. Circle. There we go. So we ask a question to our master, and then they go off and they send this to all of our agents. Those agents do their deep research, and they then send it back to the master, who then synthesizes this all back for us to read, or at least converse to. So this is another feature we could have. Another one is skeptical. So skeptical deep research, in a sense that hallucination is an issue, and that's why they include citations in the reports. This will become less of an issue over time. One way is actually having deep research critique its responses before it actually gives you a response. And the way it could do that is it tries to, especially if it's topics that are somewhat subjective and have differing opinions, it could consolidate those opinions and figure out what are the counter arguments for both, and then either present both of those counter arguments to you in a simple way to understand, or validate or devalidate some of those counter arguments to then provide the one that's actually correct with citations and even reasoning as to why it didn't include the other. So this is kind of a critique aspect into itself as it works on its research for you. And then finally is having this ubiquitous. So right now, like I said, everybody doesn't have access to this because there's associated costs. Some are free, but the highest quality ones are still expensive. My firm belief is that a lot of this stuff's going to drop, the latency and cost. And as this becomes more ubiquitous, everybody's going to have access to a deep researcher they can use, or a subsequent group of kind of a colony of deep researchers. All right, so those are our slides. We'll jump back to here to see some of the responses. And obviously, I'm not going to read all of this for you in depth. But as you can see, simply based on the length of the response, OpenAI is always the most verbose. That doesn't mean that it's always the best. But oftentimes, from my experience, it tends to give a lot of really good information associated to what it's doing. And if you see all these links here, if I click into this, OpenAI, at least it did for a few of the examples I had. Oh no, is it not going to show you here? So usually when I looked into these, there we go. It does a very specific type of highlighting where it highlights in line. So this is the whole Google thing where you can say copy link to highlight. So it does that, which is kind of nice. Oftentimes, from my experience, it's not accurate. So it usually highlights the wrong thing. So in the future, when that is accurate, it'll be super helpful. But for now, if you click into that and it brings you to the wrong place, you can just do a control find. So you can say, okay, it's talking about structured reports. I can do a control find that in this blog, and then read the source myself. So that's one interesting thing there. If you want to play with the open source variant, it gives you good responses as well. It gives you an output markdown file that has a lot of information. And usually this is quite good as well. So let's actually, I'll show you what this looks like. Okay, so I had to cut some of that out because I don't want to show you any of the API keys. So here you can see it gives you a good markdown file. So it gives you a lot of information. And this is actually quite lengthy. For an open source variant that's using O3 Mini, it's not a bad response. So if you're interested in using open source variants that give you access to some stuff, it's obviously not completely open source because you're using O3. It could be a useful alternative. With that being said, internet, hope you found this educational, entertaining, all that stuff. Like, reshare, subscribe. If there's certain videos you want me to make, leave a comment in the description and I'll add it to the queue for things we can make videos on. And if you'd like to work with me, I have a consultancy called Gradient Labs, and we work with organizations to help them implement AI internally to automate their processes. You can book a discovery call below, a free one for 15 minutes to see if there's a good fit. And with that being said, internet, I'll see you next time.